Hello friends, in this video we'll be taking a look at the trait predictor results of Clint Chimpanzee. Now, I already made a video on DNA results of Clint Chimpanzee, but in that video I did not use my trait predictor to generate the information in the video. In this video I will show you Clint Chimpanzee's trait predictor results, so running what you get when you run his raw DNA file through my program. My trait predictor is a program that is made for human DNA, so it predicts human phenotypes. It predicts polygenic risk scores for human health conditions, for human traits such as eye color, you know, hair shape and nose shape, stuff like that, human biomarkers. So I'm not sure how this will work with the chimpanzee. And the ethnic calculator results also what will be very interesting to see what a chimpanzee scores on a calculator that is made for humans, right? Because this is a calculator that's made for human populations. Um, but I do have a reference population for chimpanzee and gorilla actually in my ethnic calculator oracle, which we will see in a couple seconds. Now, Clint chimpanzee. What's interesting about this individual is that this is the first chimpanzee to have his genome sequenced. The earliest chimpanzee, or I think not animal, but the earliest chimpanzee, the earliest ape to have his genome sequenced was Clint Chimp, and he died in 2004 from a heart attack. It is actually very common for chimpanzees to die of heart-related issues. Um, it might be because of the diet. They might be not adapted very well to the diet in the zoos. I'm not sure why they die of heart attacks so much, but it is very very common for chimpanzees in captivity to have heart issues. But anyway, let's begin with the ethnic calculator results of Clint Chimp. And we will see, I'm gonna zoom in, right? And we're gonna see that the closest thing he scores is to himself, Clint Chimp, at a distance of 0.004. You might be asking yourself, why is the distance 0.0004 and not 0, right? Shouldn't it be 0? Well, the reason it's not 0 is because I actually made the oracle before I finished working on the entirety of the calculator. So I added some extra S&Ps to the calculator after I finished the Oracle. So that's why some of the reference groups are a little bit different from what they actually score with my calculator. Does it make it inaccurate? Maybe a little bit, but it also improves the accuracy quite a lot because it makes your coordinates more precise, because you get more S&Ps. So there's some trade-offs, but overall I think it's good. But he scores closest to himself. Followed by that is Oko the gorilla. So chimpanzee and gorilla are the closest populations to him. Followed by that are Shamlaka, which is a sub-Saharan African, West African human group from Cameroon. Followed by that is South African hunter-gatherer, Bob 001. Followed by that is African American. Followed by that is Mota Ethiopian hunter-gatherer. That's also a sub-Saharan African human group. Followed by that is Khoisan hunter-gatherer. That's also a sub-Saharan African human group. Followed by that is Shamlaka. That's also a sub-Saharan African human group from Cameroon. Very interesting that this Shamlaka genome is so much closer than this one. Followed by that is African American one, then Vindija Neanderthal. I don't remember which one of the African Americans is more European admixed, because one of these is more European, has more European admixture. And Vindija Neanderthal also shows up at last place here. So very very interesting oracle. As you can see, the closest populations to this chimpanzee are, itself, then gorilla, then various sub-Saharan Africans. Very very interesting stuff. All right, let's close that. Let's look at the Phenotype Oracle and let's see what phenotypes it scores closest to. What human phenotypes are predicted for this individual. So the closest human phenotype that is predicted is this, which is I would say a Central African, maybe a Bantu phenotype, followed by this, which is an East African phenotype, followed by this, which is also an East African phenotype, Nilotic phenotype, And what's interesting actually is that if you look at the two-way phenotype oracle, let's zoom out, he's actually getting modeled as a mixture of something African plus something European, or not European, but African plus Middle Eastern. That's what it seems like. Or African plus East African. Very interesting. By African, I mean like sub-Saharan. Like sub-Saharan plus East African, or sub-Saharan plus North African, or sub-Saharan plus Middle Eastern. Seems to be the models he's scoring. Very interesting stuff. All right. Let's look at what he scores with Nasak Calculator results. Nasak Calculator. So he's scoring definitely darkest brown eyes at 94 point. Let's zoom in so that you can see it better. 94.295%. And he definitely doesn't have blue damer center, or green eye color. That's completely out of the picture. Definitely does not have those eye colors. He has black hair, 100% odds of that. He has dark brown skin, 100% odds of that. Very interesting because I think the chimpanzees, they actually have white skin or pale skin in reality. Like um, if you shave them, they have white skin. So it's kind of interesting that he's scoring this for skin color. Maybe well, not maybe, but it's pretty much a certainty that they have their own light pigmentation variants that are not found in humans, and they don't carry the light pigmentation variants that are found in humans. So that's why they care. That's why they score this way with my calculator, because my calculator doesn't take into account the chimpanzee light color variants. It only takes into account the human variants for coloring. For hair texture, they score 99% chance of kinky hair. I'm pretty sure we all know that chimpanzees do not have kinky hair, so also very interesting. And for nose shape, they score a snub shaped nose at 63.3% odds. Very interesting. Now let's look at the coloring related variants. Looks like they have two light color variants in this version of HERC2, which is kind of surprising. A little bit surprising. I wasn't expecting to see any light color variants in a chimpanzee in any of these variations, but looks like we do see some light color variants here. This here in OCA2, this here in OCA2 as well, but they don't have any of the blue eye haplotypes. No BH4, no BH1, no BH2, no BH3, so they don't have any of the blue eye haplotypes. They do have light color variants in these two variations of OCA2, and these contribute to light pigmentation of eyes, hair, and skin in humans quite significantly. These are pretty significant variations. But despite that, despite having two light color variants in these two variations, they still score, 100% odds for black hair and 94% odds for dark brown eyes. So despite having these two genotypes, they still score very high odds for dark brown eyes. They're still very dark. He does not have the Eurasian variant for light skin in SLC 24A5. That's not surprising. No light color variants in SLC 45A2. He does have one of the Eurasian variants for pale pigmentation and Keto G. He does not have the Eurasian variant for light skin in this variation of Keto G. Let's see what else can we talk about here. Does not have any of the ginger variants in MC1R. Okay. Pretty interesting. Alright, now let's look at the biomarkers results for this individual. Very curious to see what they score. So for the biomarkers, he scores higher levels of vitamin D, which is really good. Lower levels of LDL and lower levels of HDL cholesterol. That's interesting. Lower levels of LDL is interesting because that correlates to lower odds of cardiovascular issues, but also lower levels of HDL. Lower levels of HDL is bad. So that leads to higher odds of cardiovascular issues. You want to have higher HDL and lower LDL. Okay, he's got higher glucose levels. He's got higher hemoglobin, which is okay, not too bad. It's kind of bad, but it's not horrible. He's got below average blood pressure, which is okay. He does not have hemochromatosis, so his level of iron in the blood is a little bit below average. Hemochromatosis would be 129 plus, and in this case, this is definitely way below that. So he's good in terms of iron levels. Below average level of sex hormone binding globulin in blood. Below average level red blood cell count in blood. Above average base pairs for telomere length. So he's predisposed to longer lifespan. Now, he did live 24 years. What is the average chimpanzee lifespan? But I mean, okay, I don't think it's fair. I don't think it's fair to say that because he died of a heart issue. He died of a heart attack, right? So he didn't die of natural causes. He didn't die of getting old and some kind of sickness from getting old. He died of a heart attack. So I don't think he died of natural causes. So I don't think telomeres. I don't think his telomere length was the thing that caused him to die. I think it was his diet and him, um, him being fed something that his body isn't adapted to. So I don't, I was gonna look up the average lifespan of a chimpanzee, but I'm not gonna do that. Okay, expected height. He's predicted to be taller than average. Very, very interesting. How tall are chimpanzees? I know bonobos are really short. Bonobos are like 4 feet tall. But how tall are chimpanzees? Let's look it up. How tall are chimps? Chimps are 5.5 feet. Okay, 5.5 feet is it's okay. It's kind of like humans. They're pretty tall. All right, let's look at the polygenic risk scores. Let's see what genetic predispositions he has. So it looks like he has average odds of kidney stones, very low odds of erythema nodosum. No risk variance for that. No risk variance for hemoglobin E disease. Very low odds for this as well. Really good stuff. High odds for migraine. Medium average odds for lupus. Very low odds for gout. Very high odds for eczema. We're gonna skip glaucoma. That's nothing interesting here. Average odds for polycystic ovary syndrome. Very low odds for cataracts. High odds for age-related macular degeneration. Low odds for rheumatoid arthritis. Wow. Okay, that's interesting. Low odds for Tourette's. High odds for epilepsy. Average odds for asthma. Low odds for leukemia. High odds for vitiligo. Average for myopia. High odds for corneal astigmatism. Okay. Average odds for primary biliary cirrhosis. Low odds for stroke. Wow, that's interesting. So maybe, and actually look at that as well. He's got actually also low odds for deep vein thrombosis and low odds for cardiovascular issues. So maybe the reason that these chimpanzees die of heart disease so much is not because of some kind of genetic predisposition. I can't really walk around that. I can't really walk around that. I feel like it is because of genetic predisposition, but they must have unique genes that are unique to them that are not found in humans that lead them to be predisposed to these conditions, to these heart issues. Because this individual is scoring very good for all the heart related stuff. Cardiovascular, he's scoring below average odds for that. Deep vein thrombosis, below average odds for that. Stroke, below average odds for that. Everything that's related to heart and cardiovascular system, he's scoring very good for that. Um, so they must have variants that are unique to chimps. They must have variants that are unique to them that predispose them to have cardiovascular issues, or at least some kind of inability to live on a diet that they feed them in the zoos. Because I feel like most of these strokes and heart attacks that these chimpanzees experience is because of the diet, because they aren't adapted to the diet. Right. So he's got lower odds of male pattern hair loss. He's got higher odds of atrial fibrillation. But that's very interesting. So pretty much below average odds of cardiovascular issues. Pretty cool. He's got high odds of ADHD. That's very interesting. and he actually does have the 2 risk variants in TOC1. Now, I do remember that every single Neanderthal that I've looked at, and every single actually non-human sample that I looked at, had these risk variants in TOC1 in DRD2. So this is really no surprise. It's very typical. It would be very surprising if Clint Chimp had anything other than this genotype here in TOC1. Um, for depression, he's got very low odds for that. Very good to see. He does have short form 5-HTTLPR, but looks like despite having short form 5-HTTLPR, he still has very low odds of depression. Very good to see. He has low odds of bipolar type 1 and low odds of schizophrenia. But by looking at the S&Ps here for schizophrenia and for bipolar, you might be catching on to the fact that the first part of the S&Ps for bipolar are also the S&Ps that are used for schizophrenia. That is because they are. That is because the S&Ps for bipolar type 1 are the S&Ps that are used for schizophrenia, plus a bunch of other S&Ps that I add on top of them. So that's why in my videos, when I do these breakdowns, I always use bipolar 1 as sort of the reference for all the thought disorders as a whole, rather than having a category for bipolar type 1 or schizophrenia, separate categories. Because bipolar type 1 is a more um, complete category. It has more S&Ps to it. It's got more S&Ps. That's why I use it in my videos all the time. Now, Clint Chimp has got higher odds of type 2 diabetes. Very interesting. And low odds of type 1 diabetes, right? He's got very high odds of Alzheimer's, and I think that's because he has risk variants for Alzheimer's and APOE. I do remember that chimps and gorillas as well have risk variants in APOE. It might be something that is common to all non-humans, but I'm not sure. Let's look it up actually. Let's look up APOE. Right, so you see 2 risk alleles for Alzheimer's and this APOE variation, and that is the reason for the really high score for Alzheimer's. It's because of this genotype right here. Um, Clint Chim has got a high score for multiple sclerosis. I'm interested. Does he have risk variants for MS in DRB1? Let's look it up. DRB1. Let's look it up. No, he does not. Oh wait, no, he does. He does. He is a DRB1 1501 homozygote. So he does carry risk variants for multiple sclerosis in HLA DRB1, but it looks like this is the only risk variant he does have. He doesn't have any other risk variants. So that's pretty good. Pretty interesting. Okay. Actually, we can look at the HLA panel and see a more thorough breakdown. HLA panel is looking pretty good. So he's scoring lower odds of autoimmune disease. I'm not expecting to see anything bad here, but let's look. So HLA-A is looking really good, and there's lower odds of multiple sclerosis here as well. No risks of B27 syndromes and HLA-B, that's really good as well. 90% reduction in HIV viral load and HLA-C, that's really good as well. Higher mean antibody levels for HLA-C, so that's really good. So actually really good genotypes overall. And he even has the protective variant from HIV here in HLA-C. There is just one it looks like there is just one genotype that is bad, and it's this one which predisposes him to multiple sclerosis. But if you look at the entirety of the genotypes together, it's really good. All right, and there is also this genotype here in DRA, higher levels of antibodies here as well. So no, this one is there's another bad genotype that leads to higher odds of allergies. So there's a couple of bad genotypes, but overall, yeah, there's a couple of bad genotypes, but overall, there's really really good stuff. All right. For cancer section, he has 2 risk variants for breast cancer of 24, really low. He has very high odds for prostate cancer, so that's kind of bad. Okay, the score for prostate cancer is really bad, and because of that, I'm assuming that he's gonna score high for epithelial cancers. Let's look it up. And yeah, he is scoring high for epithelial cancers. He's scoring 39% odds for highest odds for epithelial cancer. Definitely very much predisposed to epithelial cancers. All right, that's interesting. Right, that's interesting. Low odds for glioma and low odds for thyroid cancer. That's good. For testicular cancer, it looks like he's got. Hold on. So he's got one genotype that's homozygous, that's bad, and two genotypes that are homozygous, that's good. That's interesting. You never see that in humans. Yeah, you never see that in humans. That's how you know you're dealing with a chimpanzee, because these types of dislinkages that are consistent, these consistent dislinkages are so uncommon in humans. Like the stuff we saw in HLA, the stuff we see right now in Keto G, where you have one homozygous genotype that leads to increased risk of testicular cancer, two homozygous genotype that leads to decreased risk of testicular cancer, and them coming together in the same gene. That is so uncommon in humans, and seeing multitudes of that, just multitudes continuously in the same report, like 10 times, that is something you never see in a human result. So that's how you can tell it's not a human, it's a chimp. um he's got no risk variance for celiac disease, he's got no risk variance for GSS. Also, another way you can tell it's a chimp is that most of the stuff is homozygous. He doesn't have any heterozygous calls for anything, because there is no in his population there is no alternative alleles for any of these variations. He's got 10 risk variants for Crohn's disease out of 28, and by the way, they're all homozygous once again. So yeah, pay attention to that. Look at the stuff that he scores. Actually, let's look at the stuff he scores for everything that displays SNPs. Right, homozygous. Um, hold on. Homozygous, 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 homozygous. Homozygous, homozygous, homozygous. Everything is homozygous. Look at that. Did you notice that? You should be paying attention. You should notice that. That's very interesting, right? So that's something you can take note of and pay attention, and you will instantly notice that it's not a human result, because humans will have some heterozygosity in the result, and that's how you can tell it's a chimp, not a human. That's how you can tell it's some kind of a non-human result, right? But where were we? We were at Reifenstein's. So he's got one risk variant for absence. Oh wow, this is a heterozygous call. That's very interesting. So I did find a exception. Looks like there's a heterozygous call. Now this might be a miscall, right? So this might be a miscall. One risk variant for Parkinson's. In this case, it is probably a homozygous call as well. It says E, and the way I coded this is that if you have one or two, it does not matter. It will always say the same thing, and it will always count as one risk variant. So in this case, for this particular variation, um, because I don't remember why I did it this way. I think because it was a dominant mutation or something like that, but I did it this way for a reason. I don't remember why, but I think in this case he has homozygous call as well. He has two risk variants for Gilbert's here, homozygous call as well. No risk variants for anything like here. No risk variants for Peutz-Jeghers. This probably is a miscall once again. Jacob Creutzfeldt, two risk variants here. One. This probably is a miscall once again. So all the non-homozygous calls are most likely miscalls. So just because we know it's a chimp file, we can assume that all the non-homozygous calls are miscalls. Yeah, pretty interesting. And there is also one risk variant for Leaf Romania, which is also we can assume is a miscall. Very interesting. And now let's look over the monogenic traits and see what predispositions this Clint chimp has. So he is predisposed to warrior phenotype, which is quicker dopamine reuptake, low dopamine levels, and high stress resiliency. Interesting stuff. So he's got GG in Combs Met variation. He's got what else? Actually, he's got the Warrior genotype in MAOA, at least in this variation of MAOA. But despite that, he still scores Warrior. That's very interesting. Right. So it looks like the genotypes in MAOB and the rest of the genotypes in COMT are were the contributing factor to the reason he scores so much for Warrior. Right. He is scoring intermediate number of D2 dopamine receptors. Very interesting. So that's the reason he's scoring intermediate is because he's got all these genotypes that lead to higher autoschizophrenia and higher availability of D2 receptors, such as this one, for example, no-go learner variants. This one, which is pretty much the same thing as in terms of effect as this, which is also higher autoschizophrenia, higher availability of D2 receptor sites. This right here also leads to higher availability of D2 receptor sites. Actually, no. This leads to lower availability of D2 receptor sites. So this actually would be leading to the opposite. And then AA in TOC1. And the AA in TOC1 is a very big contributor because this leads to a significant decrease in availability of D2 receptor sites. So this is the reason why he's not scoring higher number of D2 receptors. This is the reason why he's scoring the way he is. He's scoring intermediate because of this AA genotype in TOC1. Very interesting. Okay. Let's scroll past. For autism, he's scoring high odds of autism. Okay. No risk variance with dwarfism. What else can we talk about? Does not carry any risk variance for lactase persistence. No risk variance in none of the European risk variants. Doesn't have the Arab risk variant. No risk variant. It's not a risk variant because lactase persistence isn't the risk. It's a trait. So no European variants for lactase persistence. No Arab variants. No worldwide variants. So this person is definitely this chimpanzee doesn't carry any of the human variants for lactase persistence that my trait predictor looks for. He's predisposed to a higher level of empathy based on these 6 OXTR genotypes. And chimpanzees, in case you didn't know, in case you weren't aware, chimpanzees are not known for their high level of empathy. Chimpanzees are known for pretty much the opposite. They are very, 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 very unempathetic. They're very cruel and violent. But it's very interesting that he's scoring higher level of empathy based on these 6 OXTR genotypes. Okay, let's scroll past this. There's too much stuff to talk about. Okay, so cardiovascular issues panel. He's scoring intermediate odds of cardiovascular issues. And by the way, in case you aren't making the connection, this panel is directly connected to this right here. But it is not. It is connected. There's a multiplier. There's a score multiplier. This score right here, 0.72. It is a combination of the score of the cardiovascular issues panel here and the homocysteine panel that we're going to see later on. So I think based on the results of the cardiovascular issues panel here, which is pretty much average, we can assume that the homocysteine panel is going to look pretty good. So the homocysteine panel is probably the reason why he is scoring so good for the risk of cardiovascular issues, why he's scoring so low for the risk of cardiovascular issues. Most likely it's because of the really low level of plasma homocysteine that is predicted for him. Okay, now for facial morphology panel, he's got all European genotypes in EDAR, which is very, very interesting. He's got longer mid-face length, he's got higher odds of protruding nasal bridge, larger nose size. That is very interesting. Nose pointing up, lower odds of missing teeth, and genotype for slightly thinner eyebrows and genotype for slightly thicker eyebrows. I don't know what to make of this, to be honest, because chimpanzee morphology and protruding nasal bridge does not fit in together. It does not have micropenis, does not have either of the variations for micropenis, and he's got better performing muscles, likely sprinter rather than endurance athlete. So this is the ACTN3 variant for muscle performance. I cover this in every video I make, and in this case, he's got better performing muscles like the sprinter rather than an endurance athlete. Very, very interesting stuff. He's also not an Asian flusher and has lower odds of alcoholism and normal risk of esophageal cancer. And he's got a genotype that leads to much larger brain volume. That's very rare. That's very interesting. I wasn't expecting to see that. So, that's interesting. Wow. Do chimpanzees have much larger brain volume? I don't think they do. They have pretty small craniums. But yeah, he does have this genotype that in humans leads to much larger brain volume. That's pretty cool. All right, he's got higher than average risk of heart failure due to beta blocker medications. And well, can we talk about any of this stuff here? Let's see. Let's see if I can talk about any of this. He's got greater odds of cannabis-induced psychosis, right? Very typical stuff. Yeah, let's skip past this. Doesn't have any risk variants for familiar Mediterranean fever. For albinism, let's see. Does he carry any risk variants for albinism? He has a genotype that leads to 6 times increased risk of cleft lip, and he doesn't carry variants for Melanesian blonde hair, but he does not carry any risk variants for albinism. So he doesn't carry any risk variants for albinism, but he does have a rare genotype that leads to increased risk of cleft lip. Very interesting. All right, now we have arrived to the MTHFR panel, which is a big contributor to the homocysteine panel. It is probably the biggest contributor to the homocysteine panel, aside from the CBS panel, which is the second largest contributor. And we see here that he's got really good genotypes in both the relevant MTHFR genotypes for homocysteine panel, and he's actually got an uncommon genotype here that leads to lower blood pressure, which is also good. So that's very interesting. So he's got all these predispositions that lead to lower homocysteine levels and lower risk of cardiovascular issues. And it is really surprising. Well, if he was a human, it would be very surprising that he died of a heart attack. But he's a chimpanzee, and I think he has some other genetic variants that are unique to chimpanzees that my trait predictor doesn't look for, that explain his predisposition to this condition. That's the only way I can understand it, because with my trait predictor, he's not scoring any sort of predisposition to heart issues whatsoever. I don't see any predisposition to heart issues here. Okay, let's scroll past this. Leukemia panel, we saw that. Rare diseases. Let's look at rare diseases. That's very interesting as well. Not a carrier of anything here. Not a carrier of hemophilia B. I don't see any. Oh wow, he's a carrier for ichthyosis vulgaris. So this is like eczema, I think. Yeah. Well, it's not eczema, but it's like similar to that. Eczema. But besides that, I don't see any rare conditions he's predisposed to. Right. Okay, allergies. He's got a predisposition to allergic response to nickel. Very interesting. No risk variance for Canavan syndrome. For HIV and AIDS panel, he does not have any protective variants here in C927T, but he does have the HLA-C protective variants from HIV that have a protective effect from HIV, which is really good to see. And now we are arriving at the homocysteine panel, which we see he's got a really good score on. He's got predisposition to lower homocysteine levels for sure. So he's scoring 47% for intermediate and 42% for lower levels of plasma homocysteine. So that leads to a greatly decreased risk of cardiovascular issues such as stroke or heart attack. So and this also contributed to the reason why he's scoring. This also is a big part of the reason why he's scoring so low for the risk of cardiovascular issues on the Polyenic Risk score page. So it's very interesting that despite having these scores, despite having these scoring the way he does, he's got in reality he died of a heart attack. What were they feeding him in the zoo? What did they feed him? Did they feed him McDonald's grease and burgers and French fries every day? I don't know. I don't know. Okay. Muscular dystrophy myopathy got no risk variance for anything here. Um, no risk variance for ADL. For color blindness panel, he has two risk variants for color blindness and OPN1SW. Wow, that's very interesting. Um, so he does have the risk variants for color blindness that are on the seventh chromosome. And do chimps have the ability to see three colors, tricolor vision? Hold on. Are chimps trichromatic? Okay, wow. So chimps are trichromatic, and they do see all the colors that we see as well. So, uh, I was surprised. I was expecting to see something else, but looks like they do see all the colors that we see as well. So, but despite that, he does still have two risk variants for color blindness and OPN1SW, which is, I guess, pretty common for humans as well. I mean, I've seen plenty of human samples who also had risk variants for color blindness in this gene. It's pretty common. In case you weren't familiar, this right here is on the seventh chromosome, and MW and LW are on the X chromosome. So um, it's kind of interesting. They're called very similarly. They're named very similarly, probably because they perform a similar function, but they are located very differently from each other. So maybe a little bit confusing. For FTO gene panel, he's predisposed to intermediate odds of obesity. All right, and based on 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 SNPs, he's predisposed to intermediate odds of obesity. And for syncope panel, based on 7 SNPs, he's predisposed to lower odds of syncope. For Biotic Traits panel, let's see. What can we talk about here? He's got two copies of the hunter-gatherer COTCL1 gene variant, which leads to reduced ability to process carbs and sugars, which is very interesting. He's got lower odds of motion sickness, very interesting. Higher predisposition to anger, that's very cool. Finally, I found something that makes sense, right? Finally, I found something in this result that makes total sense because chimpanzees have a very high predisposition to anger and violence. They are known to be extremely violent. They are, you know, they're compared to even like gorillas or orangutans. They're extremely violent and ill-tempered. Um, okay, let's see what else. Let's skip that. And he's predicted to belong to blood type O at 74% likelihood. Blood type A comes second at 23% likelihood, and he definitely doesn't have blood type B or AB. So he most likely has blood type O. Well, let's zoom in. Blood type O is his predicted blood type. Thank you for watching this video. I hope you enjoyed this video, and make sure you leave a like, comment, and subscribe if you enjoyed it. Thank you for watching. Check out the description of the video because in the description will be links to my trait predictor. You can download it, you can buy it, and you can run DNA files through it. And well, thanks for watching. Goodbye.